Today's video will introduce concepts of conditional probability by use of an example using sample spaces. Please note that this particular example is not included in your textbook. In a subsequent video, we will extend our understanding of conditional probability by learning how to use a contingency table to calculate conditional probability values, which is how your textbook introduces the topic. Please note that you are expected to have a firm grasp of probability concepts introduced in section 3.1 of our textbook before proceeding with today's material. Let's begin looking at conditional probability concepts with the following example. Suppose you are told that a family has 2 children. What is the probability that the 2 children are both girls? Well, we can begin solving this problem by finding the possible outcomes of having 2 children in this case. We call such a listing the sample space. So below I've listed the sample space represented by the letter S, and notice that there are 4 possible ways we could have 2 children born for this family. A couple of notes about that particular sample space. First of all, notice that each listed outcome is equally likely, and the reason why is because the theoretical probability of having either a boy or a girl is 1/2. And we can assume that each birth of a child represents an independent event. In other words, if I have a boy, that's not going to affect the probability of having either a boy or a girl for my second child. Therefore, because they're independent events, we can multiply the probability of each child's being a boy or girl 1/2 times 1/2, and that gives us that the probability of any of the outcomes listed in the sample space is 1 out of 4. Notice also that each listed outcome denotes an order of birth. Therefore, GB tells us that a girl is born first, then a boy, which differs from BG, where a boy is born first, followed by a girl. Therefore, the probability of having 2 girls is equal to 1 out of 4. In other words, the one choice where we have 2 girls in the listing of the sample space out of the 4 possible outcomes that we listed. Now, suppose we change the problem just a little bit. What is the probability that the 2 children are both girls, given that at least one child is a girl? In other words, using probability notation, we want P of GG, and then the vertical line means given that. So I would read that as P of GG, given that we have at least one girl. Again, we're going to start by looking at our original sample space, and I've listed all 4 outcomes below. Now, notice in this case, though, that we can eliminate one of the 4 possible outcomes, namely the case where both children are boys, because of the condition given that at least one child is a girl. That leaves us with 3 possible outcomes in this case. Therefore, the probability that I have 2 girls, given that at least one of the children must be a girl, is now equal to 1 out of the 3 remaining outcomes in our sample space. All right, let's look at another possibility of finding the probability that both children are girls. In this case, we're given that the oldest child is a girl. So again, take a close look at the notation. Remember, the vertical line means given that. So again, I start by looking at the original sample space. Only in this case, notice that we could eliminate 2 of the 4 possible outcomes, namely the cases where the oldest child is a boy, because of the condition that we were given that requires that the oldest child is a girl. So now the probability that I have 2 girls, given that the oldest is a girl, is 1 out of 2 remaining outcomes, and therefore the probability is 1/2. Some key things to notice in this example that I have walked through the 3 different cases for. First of all, our example started with a sample space of 4 equally likely outcomes. Secondly, when we imposed a condition within the problem that allowed us to eliminate some of the outcomes listed in the original sample space. And lastly, the smaller altered sample space was then used as the basis for calculating our conditional probability.